Hi, this is the first tutorial for the mathematical statistics, and during this tutorial we'll focus on the topic of conditional probability, which is given by as following: the probability of event A happening given the event B happening is equal to the probability of both A and B happening divided by only B happening. It is very easy to trick yourself and defy your intuition at this conditional probability definition. And you can easily convince yourself or your friends that how the conditional probability is defined. And today we will look at a famous example related to this topic, which is called the Simpson's paradox. So what is the Simpson's paradox? Let's imagine that we have three events. Suppose events A, B, and C with probability of greater than 0. And the paradox says that it is possible to have both events occurs. Like what? So the first one is the probability of events A happening given the events B and C happens is greater than the probability of A happening given the B not happening but C is happening. Also, the probability of A given B and C complement or we see C is not happening is greater than the probability of A given B is not happening and C is not happening. From these two inequality we have on hands, but also we have the probability of A given B is less than the probability of A given B is not happening. So what does this paradox mean? You first look at these two inequality. You can see that from the equation that the probability of A given B is equal to the probability of sorry. So what can you see from this Simpson's paradox? It is easily that the probability A given B and C and the probability of A given B is not happening while C is not happening. It's just a subgroup of the probability of A given B. We see it is a paradox that the inequality holds for subgroup, but it does not hold for the whole group. To make it easier to understand, or you can have more insight with this concrete example. Let's see, we have country 1 and country 2. We're going to figure out whether this smoking increases the risk of lung cancer, which has been proved to be true, but we are going to do a survey in both countries, and in particular, we are looking at the probability of lung cancer, given a smoker, and the probability of the lung cancer given a non-smoker. We need to justify this inequality, and we do a survey and we collect data from both countries 1 and country 2. And what exactly is the data you have on hand? So let's see that. From the country 1, you have smokers and non-smokers. And whether they have cancer or no cancer. Let's say this is data collected from our survey, and here we have 30 people of cancer and smokers both happening, and 290 people with non-smokers and cancer, and 170. Also, we collect data from country 2. Similarly, the smokers, non-smokers, cancer, non-cancer, which is in this term is 20, 10, 80, and 90. Oh, sorry, this is a little bit strange. From this table, you can see that the smokers in country 1 in total is 100, and the non-smokers in total in country 1 is 1,000, and smokers in country 2 is 100, and non-smokers in country 2 is also 100. So in total, we have 1,300 people. And let's look at the probability. First, we have to define what is A, B, C in the Simpson's paradox. So to make it easy, see the cancer is event A, thus the no cancer is A bar. Similarly, the smoker is event B and no smoker is B bar. Also, we have countries means the event C, and this is C bar, so B bar, A bar. Okay, so let's see. The first is the probability of A given B and C, which is the probability of cancer given smoker in country 1. C1. So that is equal to, by definition, the probability of cancer, smoker in country 1, given divided by the smoker in country 1. So we have 1300 in total, which means the probability of smokers with cancer in country 1 is equal to smoker with cancer in country 1 is equal to 30 divided by 1300, and the smoker in country 1 is 100 divided by 1300. So this ratio is equal to 0.3. Also, let's define the cancer given the non-smoker in country 1, which is exactly the probability of A given B is not happening, but C is happening. B bar and C. So the probability of cancer non-smoker in country 1 divided by the probability of non-smoker in country 1. From the data in the table, we can see that the cancer with the non-smoker with cancers in country 1 is equal to 290 divided by 13, while this one is 1000 divided by 13, which is exactly the 0.29. And from this you can see there exists a greater relation from the cancer given smoker in country 1 and the cancer given non-smoker in country 1. So the inequality of the Simpson's paradox first equality held. So let's see this similarly in what happens in country 2. We first look at the cancer with smoker given in country 2 and the probability of cancer given it is not a smoker in country 2. So, which is the probability of cancer, smoker, country 2, divided by the probability of smoker in country 2. Similarly, you have the non-smoker in country 2. And this is non-smoker with cancer in country 2. Okay, so pay attention to that when you calculate this probability, that you focus on the probability is for all the people, not for only the people in country 1 or the people in country 2. So the denominator should be on 30, 100, and then focus on it is 20, and this is 100. Similarly, this is 10. This is so. Again, when you calculate this probability, you should focus that the probability we'll calculate is for all the people, not only include people in country 1, but also include the people in country 2. So the denominator should be 1300. not 1100 or 200. Since C2 and C1 is the event in the probability. So here is 0.1, 0.2, and we also have this greater relation between these two probability. So the second inequality also holds. So finally, let's look at the combining the two countries' data. What do we have? Which is the probability of cancer given smoker. It is the probability of smoker and the probability of, sorry, this should be the probability of a smoker in both countries. Here we do not care about whether this smoker is come from. So we say this is a combining data set. Okay, so let's go back to the table. The probability of cancer with smokers with cancer in country A is, in country 1 is 30 and is 20 in country 2. So which is 50 divided by 1300, and the total number of smokers in country 1 is 100 and 100 in country 2. So the total number is 200 divided by 1300. So this goes to a quarter. And we have the non-smokers with cancer is 710. Oh, sorry, is 290 plus 10. That is 300 divided by the total number. And this is 1000 plus 100. That is 1100 divided by 1300, which is, let's see, 0.27. So here is a less than relationship. So we say the third inequality holds. From this concrete example, you can see the Simpson's paradox all is possible to exist. So let's review the data again. What is exactly this data tells us? From both data set on hand, you can see within each country, the probability of smoker having the cancer is always greater than the probability of a non-smoker having a cancer within each country. But when we combining those countries, we will have a different, or we'll have a misleading result that the smokers have a lower probability to have cancers, while the non-smokers have a higher probability to have cancers, which we say is a paradox. The result from the subgroup is not equal to or is not consistent with the result from the whole group. So we are going to find out why this is happening. So we look at the explanation. First, we know that smoking does cause lung cancer from scientific result or from scientific proof. We also know that smokers tend to live in country too. Maybe for the cultural reasons or some other reasons, but we do not care about here. This is a fact. We care about the fact. And third, living in country one increase the risk of lung cancer for some reason. Other than smoking. Where can we know that? Let's see the second explanation, that smokers tend to live in country two. From the table, you can see the total number of people in country one is 1100, but only 100 people are smokers, while this ratio increased to 1/2, which means if there is only are 200 people in country two, but there are 100 people are the smokers. So this is